So yeah, can you see my screen? No, wait, let me share. I haven't yet.
Yes, so we can see your screen on the channel.
As I said ना, हाँ ठीक है, आप चैनल देख, चैनल को म्यूट करके छोड़ दो. You can talk to me here. Even if you put the channel on, you just keep it muted. Now today we are, since we are doing some problem solving, so we will try to talk a bit. That is why this arrangement. You can be anywhere. I mean, be in Google Meet, and if you want to talk anytime, please feel free to unmute yourself and talk, and then mute yourself. And also, if you're putting it YouTube live, keep it live, just keep it muted. So yeah. So going ahead, keep your pen and paper ready with you. We will need it. So we can solve the problems also. You people can do some problem solving. So here is my first problem. Give a simple intensity transformation function for spreading the intensity of an image so that the lowest intensity is 0 and highest intensity is L minus 1. So, I mean, you might have an image which does not have a very good contrast. You know, a good contrast is one in which the pixels which has lowest values are very less and the pixels which has highest values are very high, but image may not have a good contrast. You want to convert them into an image which has got good contrast. So how would you do it? Can anyone think and tell me the possible solutions?
We can take a particular value of intensity and assign them to even lower values. Like till 30 becomes zero. Like we can say to the image, if your intensity is still 30, you become zero, and if it is above 230, then you become 255. And I think that's
No,
what
but
we.
then you have to scale each one of them. Do you see that? See, for example, it is like this. Suppose this is your input image. This is my input image plane axis, and this is the minimum. This is the minimum intensity here. You may call it something by some letter. Uh, you call it F minimum. Okay,
Okay.
and this is F maximum. Now I want to scale it. This is input and this is output image. So it says that the lowest intensity, the minimum should go to 0. So the minimum should go to 0 here. So this is my minimum, which goes to 0. Maximum goes to maximum of the image goes to the highest gray level. Highest gray level, remember, we typically write at L minus 1. If it's 256, then L minus 1, 255, something like that. And then each one of the input gray levels will scale accordingly. So this will go here and this will go here, and this will go here. So how do we ensure that? I mean, we have to design, develop some ideas about it.
So can we put a so there's an input function, input variable x, and an output function y.
Hmm.
So we have to stretch the graph in a way. Uh, so can we do y is equal to cx,
Y is
where
equal
c
to
some constant into x,
hmm.
and the constant value. So that the constant is working as a slope when we program. So we'll have to write the constant value as something. So that will be equal to y2 minus y1 upon x2 minus x1. So L minus 1 minus 0 upon fx f max minus f min. So that will become our constant. Multiply that by the image input pixel. So we'll get an output which is stretched across the whole
Can,
pixel
can, can you
spectrum.
can you tell me? I will write it here. I mean, ideally, this document is shareable, so each one of you can write simultaneously. But I still have to learn how to do that. So you can tell me right now. What did you suggest? I have devised one solution. I will tell you, but you are suggesting something, right? I mean, this has to scale to this one,
Yes.
correct? So solution that I have given is I thought that I will first shift this entire thing from 0 to this. So if from all my input values, suppose f is my any arbitrary input value. Remember f minimum and f maxima are two specific value, but f is any arbitrary pixels input value. Then all I can do is I can subtract f minimum from all the pixel values of f. So if I do that, what will happen is f minimum whenever f doesn't have value here in this range. So whenever f has the value f minimum minus f minimum will become 0. And f maximum will come over here somewhere. So all I'm doing is I'm shifting this scale, this one to 0, and maybe this one back to by an equal amount somewhere here. So now my equivalent problem is this after this subtraction is done. So my range is now in this part. Now I have already ensured my 0. Now I have to scale this to this side. Now what can I do to scale the upper portion to this side? So all I can do is I can divide this whole thing by f max, and then I can multiply everything to L minus 1. That means the ratio of this to this. So that should solve actually the problem, because when you this will be shifted somewhere here and this value should be scaled to L minus 1. Uh, Not this f minus. You will get a new f max. Uh, I should be more specific. So when you say f minus f min, this will shift here. F max minus f min, this will shift over here. So you take the ratio of this to this and multiply with this. So everything will be scaled here. There are other solutions also. I mean, one solution I can see is the reverse of this. So you, instead of shifting this interval, instead of shifting, I have shifted this interval to the left, you can shift this interval to the right, so that f max becomes L minus 1 and you scale f min to 0. So there is another alternative. Is there any other way?
Sir, can I also share it, and can you tell me if it is right way or wrong way?
Yeah, that is what I'm saying. That, let me see if this sharing works. So you can write. Are you on a laptop by any chance?
No, sir, I'm not on laptop. I'm on phone right now.
Okay.
My
Again,
laptop takes 10 minutes to start.
yeah, I mean, let it be. Now tell me what your suggestion. I will write down and then we can discuss.
I have written down. Can I share screen?
Yeah, you can. You can. Let me
Okay.
stop sharing.
So can you see the screen? Hello.
Hello.
Yes, sir. Can you see the screen?
Yeah, yeah, I can. I can.
Yeah. So this O is our output function, and I is the input. So we have to stretch the we have to stretch this two bars. I only photographed half of the to maximum x value. I mean, we have to the maximum y value from 0 to 255.
Hmm.
So we can write a transformation such that O is equal to k into I.
Hmm.
So that k, what will do it will stretch the so if I so the pixel if I'm taking pixel number one, so no wait. Yeah. So it will just stretch the graph or the y value. It will stretch if it is from 10 to 20, let's say. So it will
Hmm.
stretch it by a factor of k. So it will become 5 to 50, something like that in a proportion.
Hmm.
And the value k we can write by finding the slope, because this is an equation of straight line in a upper matrix, right?
Yeah, yeah,
So
yeah.
that k would give us, yeah. So the k would give us the m. K is equal to m is equal to y upon x, y upon y2 minus y1 upon that. So
Yeah.
that will become L minus 1 upon maximum frequent maximum is minus minimum, the x value. So by this factor, it will stretch the graph, then it will cover all of the pixel values. Like it will just stretch the
No, so
values
the
to an large.
test will be like, suppose if I put ix, ix is your input pixel, right?
Yes.
But suppose if there I put f min, then would the output pixel become 0? That is what my question is.
Okay.
Because that should be the test of your algorithm. It says that if you put f min here, your output should be 0. If you put f max here, output should be L minus 1.
So if this function wouldn't do that, so it is wrong.
I mean, that is what, if you see my screen, I'll tell you. I mean, I think you missed out something in the middle. Approach is good to begin with. Let me show my screen. So now you can see here that suppose my input is f. So suppose if I put
Sir, I
f,
can't.
can you people see now?
Yeah.
So input is f. So if I write it as f min, so f min minus f min will give me 0. So whole thing will become 0. Correct? But instead of f, if f min, if input is f max, And if I put it here, then it becomes f max minus f min. But f max minus f min is the denominator, so it will cancel out. It will give you 1. 1 into L minus 1 will give you L minus 1. So when your input is f min, it is 0. When your input is f max, then it is also L minus 1. The third test is critical. It is still centered. That is, if your input is average of f max minus f min divided by 2, no, but that need not be, because f min and f max themselves may not be symmetrical. So one has to figure that out. For example, I might, if this is my input plane and if this is my output plane, and if my two inputs are not f min and f max are not symmetrical about this axis, suppose they are lopsided on one side, then this will scale here, this will scale here. The center of this will go center of this one. So that is the third test that one can perform. So I hope, I mean, you people have followed it. Any question or doubt at this? Can we move to the next question? Yes, no?
Yes, sir.
Yes, very good. Well, let's go to the next question. Find all the bit planes of the following 4-bit images. So can you all do that? These are all 4-bit images. So bit planes निकालना है आपको. तो जरा आप लोग जरा करेंगे. How do you write 0 using 4 bits? At least find the first bit plane and last bit plane. How do you write 0 using the 4 bits? Can anyone tell me? I mean, that everybody should know. 0, 0, 0, 0. Am I right? How do you write 6 using 4 bits? Or 1? Let me go ahead step by step. 0, 0, 0, 1 or 1, 0?
So 0, 1.
Yeah, that's 0, 1. How do you write 8?
0, 1, 0, 0.
0, 1, 0, 0.
No. 1, sorry. The 2 raised to 3, because
2 raised
the
to
fourth
3.
bit should be 1.
Fourth bit is 0, no? Right? And
Fourth bit is 1 and third is 0, right? This is 1. The last, that
yeah.
first would be 1, second
Yeah.
0, and
8,
third
8,
0.
3 bits will count only up till
1, 0, 0, 0.
yeah, yeah. 3 bits will count only up till 7. Do remember. Don't
Yes.
forget. 8 you want, so you have to make it 1, 0, 0, 0. And the 6, how do you do? So
0, 1, 1, 0.
0, 0, 0,
0, 1, 1, 0.
0, 1, 1, 0. Yeah, can you finish writing all this? I'm just writing the last one now. On your pen paper, just write the code for all of them. 10 you will write 1, 0, 1, 0. How do you write 9? So 8 plus 1. So on and so forth. So please finish writing it up on your. Now tell me, we have to find the bit plane. So let me find the D0 bit plane. D0 means it's a least significant bit plane. So what is the least significant bit plane? So you will take the least significant bits from all. It will become 0, 0, sorry, 0, 1, 0, 0, 0, 1, 0, 0. What will be the least significant bit over here? Can you tell me? Anyone? Second line.
0011. That's the second line, right?
Yeah. 0, 0, 1, 1. What is the least significant bit in the third line? Anyone else?
1100.
1, 1. Others, please check if you are finding any inconsistency. Let me know. Last line, please tell. Two digits I have, 1 and 0. What about the first two digits?
10.
1, 0. Okay. So this is my D0 plane. Tell me about D8 plane, or D7 plane. What is D7 plane?
MSB.
Yeah, most significant plane. D, not D7, I'm so sorry. This is 4 bit only. So D4, D4 no, D3 plane. Counting will be from 0 to 3. So D3 plane. Oh, wait, using eraser. So can you tell me what is D3 plane?
0010.
0, 0, 1, 0. That values I have here. Second line,
All zeros.
so all are zeros because you have nothing in those higher planes. Third line,
0 triple 1.
0, triple 1,
Then double 0 double 1.
and then double 0, double 1. Now one significant question which is asked that which one has more data. You will find that 1, 2, 3, 4, 5, 6. This has 6 data ones. This is 1, 2, 3, 4, 5, 6, 7. This has 7. So this has more data than this one. Slightly more data. Okay. Now you people, I give you a little bit of homework on this. Think about a computer algorithm in which this matrix is fed. You convert them into binaries. So you have the binaries and you want to separate these bit planes. So think about it. One can do it very easily. Go to the first one, take the least significant bit, save it somewhere else. But how to do it in a computer program? Think about it. Okay, going ahead. Let me see what else do I have. This is something which is similar to the first problem, so I'll just explain If you are on phone, I can enlarge it a bit. An image with the intensity in the range 0 to 1 has the PDF probability distribution function, technically the histogram, shown in the following figure. It is desired to transform the intensity level of this image so that they will have the specified PZZ shown in the figure. Assume continuous quantities, find the transformation that will accomplish this. So you have an image which has a histogram like this, like it has lot of dark pixels but very few bright pixels. And you want to convert it into this kind of image. So very few dark pixel, histogram should be like this. So what kind of function do you use to make this from this? So can you people think and tell me? Take 2 minutes. Yeah, anyone has got an idea about it? All these problems, I mean, this one and the previous one are the problems like, you are doing x is equal to k times y. So if this is my y and this is my x, I want to find out k. So k is a ratio, something like that. That approach should work. Yeah, somebody is telling me something. Can you go ahead?
So here if we subtract 2 from PR, we'll get PZ, right?
We subtract 2 from these values. So let's say let's take an let's check that. So let's take an arbitrary value here as let's take an arbitrary value as P, or let me say Pi, and here my value, no, it's already given. In fact, I don't have to take I, it's PR, and this is PZ. So you mean to say that you subtract 2. So how do I do? PZ is equal to, what do I write exactly?
PR minus 2.
PR minus 2. So let's try that. So if I do this, so let me check for the input. So when PR is 1,
I think it will not work there at the
it
last
will become
point.
1 minus 2. It will become minus 1. But then PZ is nowhere is minus 1. When this is 1, this should be 2. And when PR is 0, or when PR is 2, this should be 0.
So can we take the mod of the RHS?
Mod of the RHS. चलो mod लगाते हैं भाई.
So PR will become 0 at the extreme point, right? It's not 1, no? 1 is the value of R.
1 is the value of R. sorry. So PR at this point is 0. So when PR is 0, your PZ is 2. Wait a minute. Yeah. So when PR is 0, PZ is 2. Correct. Mod will solve the problem. When at this point, what is the value of PR? 2. And PZ is 0. So 2 minus 2, 0. Good. So why not doing 2 minus PR? So you don't need mod. Am I right?
Yes, sir.
So if you use this kind of transformation function, you can see how mathematics is playing a role. We call it computational photography or computational image processing. So what is happening here is this image. Remember, these are the input gray levels, and this is the probability distribution function. So it says that there are a lot of dark pixels in this region. Okay, I should use some. I mean, this I'm finding this Jamboard thing very fascinating. This has brushes and highlighters and a lot of things. So in this part, you can see that there are a lot of pixels and they are fairly, the image is predominantly a dark image. Now if you take this image and you subtract from 2, each pixel subtracted from 2 will give you a predominantly a bright image, because most of the pixels are now moved towards this end. So this gives you a transformation. So good. Let's go ahead. You are given a following kernel and image.
So, just a question. In the previous
Yeah.
question, the extreme end vertical line, how is that coming into this transformation? Because we'll just get using this transformation, we'll just get a line, we'll just get a diagonal line.
Vertical line, I don't think it will come, because if you I think vertical line has been drawn just to give a representation. This is
All
what
right, okay.
my
Okay.
feeling is, because if uh, if you consider a vertical line, then this will become a multi-valued function. Like for z is equal to 1, your pz has
Exactly.
multiple values, and it becomes a very challenging
Right.
you know. So it does not make sense to me, at least. So all I'm feeling is this has been drawn just to give a shape to the transformation function. These are the simpler transformation functions. I mean, you can have more complicated transformation functions as well. I'll just demonstrate one. For example, if I take this only as input, but suppose I want, wait, I would take this only as input, but at the output, let's say that I want this kind of output. Are you getting my point? That I want this kind of histogram. This is my input histogram, and I want this kind of histogram. What could be my transformation function? So
Fourier transform. I mean, I
not,
guess.
no, not Fourier. These are simple mathematical linear. This will be non-linear though. But all I'm saying is these are simple mathematical relations, not Fourier. We are not getting into Fourier domain as of yet. So all I'm trying to tell you that, and now what would this image look like? So this image has very less pixel on the very dark side and very less pixels on the bright side. But majority of the pixels are in the middle. Here, most of the pixels are on the darker side. In this one, which they book, the problem has drawn originally, all the pixels are on the brighter side. So there could be multiple possible transformation functions. So this problem is just to give you a hint of it. Now this vertical line, yes, I don't think right now we can consider it, because that will make it multi-valued function and perhaps fairly complicated to deal with. Oh, sorry. Yeah. Now let's go to the next. You are giving the following kernel and image. So there is a kernel 121.242.121. There is an image. This is an image. This image has 3 bright pixels and rest of them are dark. Okay, it will be interesting how would this image look like. If one has to draw this image, then I mean I was exploring this more and I realized that this is a fairly interesting tool to take a lecture. I still don't have a pencil, so once I invest in a pencil, perhaps it will become much better tool. But still it is very interesting. So this image, suppose this is black. This is, I've shown it gray, but assume that it is black. And my fear is that if we get so much used to these tools, then if the college reopens, then we will be in trouble. Yeah. So here. So assume that this is symmetrical, of course, so center. So imagine that this gray is black, so surrounding is completely black. So all these zeros will represent the blacks, and these ones will represent the center white. So that kind of image is given to us, and we have to be given a window also, kernel, using which we can give a sketch of the area encircled by the large ellipse. So that ellipse is there. Um, if you look at the lecture videos or the book, they have drawn everything in an ellipse. But so how do we do this? So normally, let me do it here only. So it says that the kernel is centered at point 23. So which is 2, 3, second row, third column. So this is the first row. Sorry, this is the 0th row. This is the first row and this is the second row. Okay, and third column, again I really don't know how this question is counting. So just to make it interesting, I will take 2, 3 as first row, second row, first, second, third. So if you look at it, my 2, 3 is going to be this one. This is my 2, 3. So at the location of 2, 3, the center of the kernel will come. So 4 will come here. So I will write in a small letters 4. If the 4 comes here, then where would the other parts of the kernel go? So 2 goes here, this 2 comes here, 1 goes here, 2 goes here, this 1 comes here, 1 comes here, this 2 comes here and 1 comes. That's how the kernel will fix. Can you tell me the final value of the central pixel? Anybody?
6.
How much is that? 6.
Yes, sir. 6.
6. So the final value of kernel pixel, you will get 6. How do you get it? Very straightforward. You multiply the window to the image. So you multiply 1 to 0 wherever the pairs are written. So 1 into 0 is 0, 2 into 0 is 0, 1 into 0 is 0, 2 into 0 is 0, this is 0, this is 0 and this is 0. Only surviving factors are 1 into 4 which is 4, 1 into 2 which is 2, 2 plus 4, 6. So the new value of this pixel after this multiplication will give you 6. Okay. Then you go to the, then this is generally, then this is my kernel which is mounted at this origin, is then shifted to the next one. If you shift to the next one, you remember it goes out. So what do you need to do in order to sort out this problem? You remember we need to do padding. So you add extra zeros, your new center will be here, and again you do the convolution. Here everything is 0, it will yield you 0 as the answer. So on and so forth. So I hope everyone has got this, right?
Sir, the center will shift to the next 0, no? Besides 1.
No, I am unable to hear you. Can you tell me again?
The center, I mean the 4, will shift to the next 0 after 1.
Yeah, after 1, it will shift here. Oh, yeah, you are correct.
So
So
there won't be any padding
padding
in
की
here.
अभी जरूरत नहीं है. It will be needed when it shifts. Will shift one more time. Yeah, you are right. Yeah, I made that mistake. Thank you. So this is how the mechanics of the filtering work. Master it in your concept, master it in your theory, and master to write this convolution in your practicals. This is going to be very, very helpful. Okay. Let's take some another kind of question. Develop a procedure for computing the median of n by n neighborhood. So n by n neighborhood is given. You might be given any number. Yeah, so you people think and tell me. I'm just writing an n by n neighborhood. I will write a simple 3 by 3 neighborhood. So yeah, so this is my 3 by 3 neighborhood. Develop an algorithm for computing the median of n by n. n by n is 3 by 3. So इसका हमको median निकालना है. So कोई suggest कर सकता है कैसे करेंगे? What is median? Can anyone tell me?
So if we arrange the elements in ascending order, it is the element which lies in the middle.
That's right. So, and median is nothing but an element which lies in the middle of a sequence which is arranged in order, ascending or descending. Correct? So how do you, now to begin with, these numbers may not be in order. In an image, these are the intensity values and they may not be in order. So you will have to bring them in order. That will be the first step. How do you do to, what do you do to get them in the order to begin with?
So those sorting.
You do run a sorting algorithm. What are the essentials of a sorting algorithm? If you have done it, then you know. But if you have not done it, then next few minutes are for them. Sorting is very important problem. So if you have not done the sorting, here is the algorithm. You read the first number. So step one, and I'm telling you how to write an algorithm. If you don't know, please learn. Read first number or enter first number or whatever. Then what do? You read second number. Very simple. So instead of writing all these, I will just write second number. Then what is the next step? Can anyone tell me now? Those who have done sorting?
Compare both the numbers.
Compare. So next is compare. Compare, you find out greater than or equal to. Compare the two. Suppose if I am now, our target should be decided. Suppose if I'm going in ascending, okay, then what I have to do, if I'm going in ascending, then if the first number is less than second number, don't do anything. I will call it, so if my first number is equal to second number, you don't do anything, no issues. You do something when the first number is larger than the second number and you have to go in the ascending order. Are you getting it? So if the first number is larger than second one, so I may call it n1 greater than n2 if. Then what do?
So then assign the values of n2 to n1.
Yeah, then you assign the values, you swap the values basically. Okay, you switch the positions, but you cannot switch the positions just like that, because in computers, if you assign the value of n2 to n1, n1 value is lost. So what you do is you,
So create a temporary variable.
yeah, you create a temporary variable. So assign n1 to some type of temporary variable. Remember, this is a very common and very essential step. Then you take n2 and you assign it to n1, and as a third step you take n sorry you take temp, which holds your n1, and what do you need to do next? Assign it to n1. So this is my swapping. If it is found to be greater, then the next step is, what is the next step? You read the next number. Very straightforward. Take these two for example. If A11 A12 से छोटा है कुछ मत कीजिए, A11 A12 के इक्वल है कुछ मत कीजिए, A11 A12 से बड़ा है तो इनको स्वैप कर दीजिए, so that the smaller number comes here, bigger number goes here. Simple. Read the next number and then repeat this part. Compare the two once again and then go down. Keep repeating it till you reach at the end of this. Okay? Once the process is finished, you get an ordered list. Ordered list means the smallest will be this and largest will be this one. Now, can you tell me how to find the median? How to?
So
Yes.
n to n,
Pardon?
and so we have to find the total number of that will be like n into n in this case, and then divide by 2.
Right now
And
it
take the
is right
integer
now it is
value of
n
it.
into n, so it is equal sized. So assume that n is odd also. So you have some odd numbers towards the end.
Yeah, so we take the either integer value of n into n by 2.
Yeah. So in fact, basically you have to run a counter also here. Some kind of counter you have to run. So update your counter and figure out the middle count. So in fact, you don't have to run your algorithm till the end. Once you reach to the middle of the list, you have already obtained your median. Okay. So this is another example that you people can work on. I think I have one more problem. But no, this number 6 looks blank. Oh, that means we are at the end. So fine. So we end the lecture part and the live streaming.